Welcome to the course of differential equation. In this session, we will discuss about the method of undetermined coefficients part 6. We already discussed 5 sessions before. It is that to solve non-homogeneous linear differential equation with the constant coefficients. See, we know that the corresponding, the general solution of equation 1 is, that is actually y is equal to yh plus yp. See, yh is the complementary function. We have yh is the solution of the corresponding homogeneous part, is the solution of the corresponding homogeneous equation, that is the equation, homogeneous equation, that is the equation ay double dash plus by dash plus cy is equal to 0. Ay double dash plus by dash plus cy is equal to 0. See here, yp is the particular solution that we need to find, that is a special solution for this non-homogeneous equation. We discussed 9 methods to find this homogeneous equation. See, we have a table here that is based on the value of r of x. Based on if r of x is k e raised to px, that is if r of x is an exponential function, then we have choice for yp as c e raised to px. And similarly, if it is a polynomial function Pn of x, then it have choice for yp as kn x raised to n, kn minus 1 x raised to n minus 1, etc. k1 x plus k naught. We just apply yp dash and yp double dash in original differential equation, that is 1, then we will get the value of k1, k2, k naught, k1, k2, etc. kn minus 1, kn, and we can apply here so we will get the particular solution yp. Maybe they have a choice for that r of x may be the trigonometric functions, that is of the form sin px and cos px. Then we have choice for yp as a cos px and b sin px, and what we did it is that as we done before itself, we just find yp dash and yp double dash, and then we will apply to original equation the given differential equation, then we will get the value for, we can find the value for a and b. So, again we will get a particular solution on that context. Maybe they have other choices for r of x, as if r of x is the combination of the exponential function and trigonometric function, that is of the format of k e raised to px cos qx and k e raised to px sin qx, then the choice for yp as e raised to px cos qx plus b sin qx. See, similarly, maybe the r of x is a combination of the polynomial, product of the polynomial nth degree polynomial into an exponential function, then definitely we just multiply, we already found here this is the choice for yp for the exponential function, and here we have a choice for the nth degree polynomial function, their product is actually the choice for yp. So, finally, we will have choice of r of x as the product of exponential function and a polynomial function and trigonometric function. Then we can find, as we done before, product of the polynomial function and exponential function and trigonometric function is there. Here we have two choices there, we have kn x raised to n plus etc. plus k1 x plus k naught into e raised to px into cos qx plus ln x raised to n plus etc. plus l1 x plus L naught into e raised to px into sin qx. Here all k naught, k1 etc. kn, L naught, L1 etc. ln are the constant values that we need to determine by applying yp and yp double dash, yp dash in original equation 1, the given differential non-homogeneous differential equation. After applying that all things, we will get the particular values for these constants, and we just replace that constants here. So, we will get a particular yp for to us. See, dear students, that we need to find, and also here we are discussing one more rule, that is the rule B. We already discussed the modification rule and the sum rule. Here this is the combination of the modification rule and sum rule. See, my dear students, if r of x, see we have the general form of the linear non-homogeneous differential equation as ay double dash plus by dash plus cy is equal to r of x. And see here r of x create the non-homogeneous part in RHS. So, is a sum of function, r of x is a sum of functions from the column 1, that is we discussed column 1 as here. See here this is the choice of r of x. Maybe r of x is any of these functions from this column 1, either sum of exponential function and a polynomial function, or sum of exponential, polynomial and trigonometric function, or sum of their combination. In all cases no problem, any of that choice is there, sum of any of the functions from that column 1 in the table, and if we at least one of the function is also solution of the homogeneous equation. Any of these functions, see dear students, any of these function, here we used we have choices for this r of x, these are the choices for the r of x. Maybe any of this r of x or choice of yp have a choice, maybe they are the solution of the corresponding homogeneous part, that is the yh. We discussed here, we can find the yh, the complementary solution for the corresponding homogeneous parts. So, any of the choice of r of x, any of the function of in r of x, maybe some of the many functions from the column A, that may be solution of the homogeneous part. Then equation corresponding to 1, that is this one, the equation corresponding to the homogeneous equation corresponding to 1 that have similar solution like r of x, or some part of the r of x are the solution of the homogeneous equation. So, on that case we use modification and sum rule. We already discussed the modification rule and sum rule, and we use both the rules we use for the choice of yp, that we can illustrate with an example. So, dear students, come to the next example. In this example we solve the differential equation, non-homogeneous differential equation, that is y double dash minus 2y dash, y double dash minus 2y dash plus y is equal to, plus y is equal to t plus e raised x plus e raised to x is there. This is our non-homogeneous equation 1. See, while seeing this equation itself, we understood it is that this is the non-homogeneous equation, that is linear non-homogeneous differential equation with the constant coefficients. See, we have the corresponding, this one homogeneous equation is, the corresponding homogeneous equation is actually, the corresponding homogeneous equation is actually, we have the y double dash minus 2y dash plus y is equal to 0. So, dear students, our next time to write the auxiliary equation. So, we have the auxiliary equation as this is equal to instead of y double dash, here we have m square minus 2m is there and plus 1 equal to 0. Okay, fine. While seeing this different this auxiliary equation, we can have this as m minus 1 whole square is equal to 0. M minus 1 whole square is equal to 0. Fine. So, we have choice for m as m1 is equal to m2 is equal to 1. So, the case, in case of the case is double root. On that case, we have the general solution for YH, that is homogeneous part. Therefore, general solution of homogeneous part, general solution of the homogeneous part, that is YH is equal to C1 e raised to, C1 plus C2 C1 plus C2 x e raised to C1 plus C2 x e raised to, that is the mx, C1 plus C2 x e raised to mx, that is m1 equal to m2 is equal to minus 1. Therefore, C1 plus C2 x e raised to x. See here we have the functions involving here, we have two choices here, that is we have y1 as this is equal to c1 e raised to x, therefore e raised to x is y1, and y2 the functions solutions corresponding to homogeneous part, that is equal to x e raised to x is there. See dear students, we already have the solutions as e raised to x and y2 as x e raised to x is there. See you can come back to our r of x, see r of x is actually x plus e raised to x is there. See here we have r of x is equal to, but we have r of x is equal to x plus e raised to x is there, x plus e raised to x is there. See here this one x is, this is the part of polynomial function, this is the part of the polynomial function, and here we have one more function is there, that is the exponential function is there. So dear students, we can say that the r of x is actually sum of two different forms that we discussed here. See here we have r of x is actually the sum of the exponential function and a polynomial function. So before going to that, we would like to ensure your attention to here, this is c, here we have e raised to x is there and x e raised to x is there. So see x plus e raised to x is there. So we are unable to consider e raised to x for yp and x e raised to x for yp. So there have only choice, one choice, it is that have to multiply with x square. So we have the choice for yp as, so choice for yp as yp is equal to this is equal to yp is equal to, here we have first one polynomial function of first degree, therefore k1x plus k naught is there, k1x plus k naught is there, and also here we already discussed it is that e raised to x is impossible, x e raised to x is impossible, therefore x square e raised to x is there. So would like to say this is equal to some c x square e raised to x is there. Find this is yp actually, and we have to apply this all things to our equation 1. So for that we need to find yp dash and yp double dash. So dear students, see here we have yp dash as, yp dash is equal to, see yp dash is actually k1 into derivative of x, that is k1, k naught is 0 and c into x square into e raised to x is there. X square is the first function and e raised to x is the second function, therefore c into x square into derivative of e raised to x plus e raised to x into derivative of x square, that is 2x into e raised to x is there. Okay, fine. Now again we can differentiate one more time to find yp double dash. So yp double dash is equal to derivative of k1 is equal to 0, therefore and c into inside the bracket we have here, this is we treat x square as the first function, this is the second function, 2x is first function, e raised to x is the second function. So simply we can take maybe e raised to x is outside also, no problem. So I would like to rearrange this one yp dash as, see dear students, we can write yp dash as yp dash is equal to k1 plus c e raised to x into x square plus 2x is there. Okay. So here we have while evaluating yp double dash, we can consider this as first function and this as the second function. Okay. So yp double dash is equal to derivative of k1 is equal to 0 and c is the common constant and e raised to x into derivative of x square plus 2x, that is equal to 2x plus 2 plus x square plus 2x into derivative of e raised to x, that is e raised to x itself. Fine. So we found yp and yp dash, yp double dash is there. We have to apply these all things to equation 1. Apply yp, yp dash and yp double dash in equation 1. The equation 1 is actually, we have the equation 1 as say y double dash minus 2y dash plus y is equal to y double dash minus 2y dash plus y is equal to x plus e raised to x is the equation 1. Okay, y double dash plus 2y dash plus y is equal to x plus e raised to x. See dear students, so I have to replace yp dash, yp double dash as, sorry, y dash as yp double dash and sorry, y double dash as yp double dash, y dash as yp dash, and this is yp. Fine. So dear students, we have this is equal to yp double dash. We already found yp double dash as c into e raised to x is there. So we can write this as yp double dash is equal to c into e raised to x into, and again inside we have e raised to x is there. We take both the e raised to x is outside, and we have this is x square plus 2x plus 2x 4x plus 2. So x square plus 4x plus 2, x square plus 4x plus 2. See here we have x square plus 2x plus 2x is 4x and plus 2 is there. Fine. And the next is minus 2 times of this one yp yp dash, and the yp dash is equal to, that is k1 plus c e raised to x into this is 2 into k1 plus c e raised to x into k1 plus c e raised to x into x square plus 2x is there. Okay, x square plus 2x. Okay, x square plus 2x is there, and finally we have plus yp is here. So we have yp as, that is yp is equal to this is equal to k1x plus k0 plus cx square e raised to x. Therefore this is equal to plus yp as k1x plus k0, k1x plus k0 plus cx square e raised to x is there. Cx square e raised to x is there. Okay, k1x plus k0 plus cx square e raised to x is there. So dear students, here we have finally in opposite side we have x plus e raised to x is there. Okay, fine. So we have this is equal to, again we have c e raised to x is here, and here also an e raised to x. We can take the functions with e raised to x. Therefore we will have here it is equal to c e raised to x into, okay, e raised to x into, okay, e raised to x into c e raised to, we can take c e raised to x is also outside, no problem, c is there everywhere. So c e raised to x into c e raised to x into here we have x square plus 4x plus 2, and here we have minus 2 x square minus 4x is there. So x square plus 4x plus 2, x square plus 4x plus 2, okay, x square plus 4x plus 2, minus 2x square minus 4x is there, minus 2x square minus 4x is there, and also minus 2x square minus 4x is there, and finally here we have c x square e raised to x. So one more x square is there. So plus x square is there, and plus c we taken all the coefficient all the terms with e raised to x, c e raised to x that we already used, and minus 2 k1 plus k1, see minus 2 k1 plus k1, that is equal to minus k1, sorry, that is equal to minus k1 minus 2k1 plus k1, that is minus k1 and also plus k naught is equal to plus k naught is equal to, see here it is equal to x plus e raised to x is there, x plus e raised to x is there. Okay, fine. And we have this is we can write this as c e raised to x plus x square minus 2x square plus x square plus x square 2x square minus 2x square is there, that we can cancel, x square minus 2x square x square we can cancel. See here we have 4x and minus 4x is there, plus 4x and minus 4x is there, that also we can cancel. And finally, there remains only the value plus 2 there remains only there, therefore 2c therefore 2c e raised to x minus k1 plus k naught is equal to x plus e raised to x is here, minus k1 plus k naught equal to x plus e raised to x is here. See here we have this is equal to okay minus k1 sorry, finally here we have k1 x is here, I am sorry, just I did one mistake here, this is equal to k1 x plus k1 x plus k naught is there. So, c e raised to x square. So, here k1 x is there, k1 x plus k naught is there. So, minus 2 k1 is there, sorry, here we have minus 2 k1 plus k1 x is there, minus 2 k1 plus some k1 x plus k naught is equal to some k1 x plus k naught is equal to x plus e raised to x is there. Okay, fine. So, here we have this is equal to minus 2c e raised to x plus minus 2 k1 plus k1 x plus k1 x plus k naught plus k1 x plus k naught is equal to x plus e raised to x is equal to x plus e raised to x is here. Okay. So, we can compare the coefficients of e raised to x. So, compare, we can compare coefficients of e raised to x, therefore, e raised to x that is equal to 2c is equal to 1. Okay. That implies c is equal to 1 by 2, that implies c is equal to 1 by 2. Fine. Now, c is equal to 1 by 2. Now, we can compare the coefficient of x. Okay. Now, the next compare coefficients of x. Okay. While comparing the coefficients of x, we will have here we have k1 x and there is an x is there, therefore, k1 is equal to 1. So, therefore, k1 is equal to 1. And finally, we have that is equal to minus 2 k1 plus k naught is there, minus 2 k1 plus k naught, minus 2 k1 plus k naught is there, that is the constant values, but here there is no constants, therefore, the value equal to 0 is equal to 0. Okay. Therefore, we have this is equal to minus 2 k1 is 1 plus k naught is equal to 0. Therefore, k naught is equal to, we will took minus 2 to here, therefore, k naught is equal to 2. Okay, fine. Now, k naught is equal to 2. We have k1 is equal to 1 and we found c is equal to 1 by 2. That is all. We can apply here in yp, the yp as k1 x plus k naught plus c x square e raised to x is here. So, we found yp as, therefore, yp yp is equal to k1x, that is equal to k1 is equal to 1 is there, and we found k1 is equal to 1, and k0, that is k1x plus k0, k0 is equal to 2, and finally we found the value of c is equal to 1 by 2, 1 by 2 c x square 1 by 2 c x square e raised to x, therefore 1 by 2 x square e raised to x is there. So, 1 by 2 1 by 2 plus 1 by 2 x square e raised to x is there. So, this is yp, now we found yp, therefore, general solution of the given, therefore, general solution of given non-homogeneous, general solution of the given non-homogeneous differential equation is y is equal to yh plus yp, y is equal to yh plus yp. That we found we already found the complementary solution yh as, say we have yh, come back we have yh here, we found yh as c1 plus c2x e raised to x is there. So, we have c1 plus c2x, this is equal to c1 plus c2x e raised to x is there, plus that is the yp, yp is equal to 1 by 2 x square e raised to x plus x plus 2 is the general solution of the given non-homogeneous equation. So, we found the general solution of the given non-homogeneous equation. See, my dear students, you can find many such problems from the literature of the differential equation. Many engineering mathematics students are frequently using this differential equation. You may try to find more problems. I will give you some examples, assignments. So, assignment as solve the non-homogeneous differential equation with the method of undetermined coefficients y double dash minus 4y dash, y double dash minus 4y dash plus 4y is equal to t cube into 2 raised to t e raised to 2t, that is x cube into, I would like to say x cube into e raised to 2t plus x into e raised to, instead of t I would like to consider as independent variable as x, therefore, x cube e raised to 2x and x e raised to 2x is here. I would like to give you one more question. Solve an IVP, the initial value problem. Solve the initial value problem. See, y double dash minus y dash, y double dash minus y dash minus 2y is equal to 3 e raised to 2x, 3 e raised to 2x, where y of 0 equal to the initial conditions, y of 0 equal to 0 and y dash of 0 equal to minus 2. Okay. Solve both these two questions by using the method of undetermined coefficients, and also you can find many problems from the literature of the differential equation. Try to solve such kind of differential equation. Definitely you can enjoy the concept of the finding solutions of the non-homogeneous differential equations. Thank you for watching this video. Continue your watching. Thank you very much.